Okay, today we're going to start talking about gravitation again. We did talk about gravitation last semester, but now we're going to kind of see where it comes from. So Newton's law of universal gravitation. Well, we know, first of all, gravity is an attractive force between any two masses. So Newton's law of universal gravitation is to describe this attraction between two different sized masses. Okay, so let's say we have mass 1, and there it is, and we have mass 2, there it is, and they are separated by a distance of r. They feel a certain gravitational force between one another. So whether they feel it or not. So there's this gravitational force between all two objects that have mass. For example, the person sitting beside you, there's a gravitational force between you and them. You don't feel it currently because you're currently feeling the gravitational force between yourself and Earth. Since it's so much greater than the gravitational force between you and the other person, you don't actually feel that force. So if we were to increase mass 2, the mass of mass 2, keep the same distance, well, if we increase the mass of something, we're going to increase the force as well. If we decrease the radius of them, so if we bring them closer together, we're also increasing the force. So increasing the mass increases the force, and decreasing the radius increases the force. So let's write an equation that relates those two things, the mass and the radius. So that is Newton's law of universal gravitation, which is F of G equals G m1 m2 over r squared. Okay, let's find the units of this capital G. This capital G is a gravitational constant. So in order to find the units for this gravitational constant, we need to know the units of m over r squared. Well, we know kilograms times kilograms is kilograms squared. And we know r squared is meters squared, so it's a distance. We know that we want newtons on our left-hand side because that's the units for force. So that must mean our gravitational constant is equal to a newton times a meter squared over kilogram squared. If we went ahead and evaluated these units, you have kilograms squared canceling, meters squared canceling, you're left with newtons, which is what we want force of gravity in. Okay, so let's write down what r is. It is the distance between the center of masses. The center of mass is the location where if you put something on a balance, it would balance out. So in regards to our spheres, the center of their mass is pretty simple. It's the center of the object. Okay, it gets a little more complex when we talk about different objects. So our mass, m is mass, and it's measured in kilograms as always. And you need the gravitational constant. It is 6.67 times 10 to the negative 11 Newton meters squared over kilograms squared. You don't need to remember this number. It'll be given to you on the AP sheet. Okay, let's do an example. Example 1. What is the force of attraction between the sun and the earth? So there's a few things you always need to know when you're finding force due to gravity between two objects. We need to know both of their masses. Okay, so the mass of Earth is equal to 5.97 times 10 to the 24 kilograms. And the mass of Sun is equal to 2 times 10 to the 30th kilograms. We also need to know the distance between their center of masses. So the radius is going to be 1.5 times 10 to the 11 meters. This value, as well as the masses for any given planet that you need, you can always look up online and find. On the AP test, it would be given to you. On my test, it would be given to you. But for the homework, you're going to have to look some up. Okay, so F of G is equal to G m1 m2 over r squared. Let's go ahead and plug it in. 6.67 times 10 to the negative 11 Newton meters squared over kilograms squared. multiplied by the mass of Earth, so 5.97 times 10 to the 24 kilograms, times the mass of the Sun, 2 times 10 to the 30 kilograms, divided by the distance between them, so 1.5 times 10 to the 11 meters squared. Okay, let's just evaluate the units before we solve. So you have a meter squared in the denominators, that cancels with the numerator. Kilograms times kilograms is kilograms squared divided by kilograms squared, cancels. We're left with newtons, which is what we want. Great. So I'm going to show you two different ways to solve this. First way is estimation. Okay, so in order to estimate using order of magnitude, you know this kind of mathematics, you've learned it all, you have all learned it before, but let's just review quickly. So we're going to find the closest number to the numbers that we have up here. And we're going to round. So 6.67 rounds to 7 times 10 to the negative 11. 5.97 times 10 to the 24th rounds to 6 times 10 to the 24. Okay, and 2 times 10 to the 30th is already good. We want to round to easy numbers that are easy to multiply and divide together. So 1.5 squared ends up, if you multiply 1.5 times 1.5, you get like 2.25. So 2.25, if you want to take the closest number to that, you're going to get 2 times 10 to the 22nd. Okay, so we have to simplify this, force of gravity. We end up getting, we want to multiply our factors together. So 7 times 6 times 2, you get 84. And then we multiply these other factors together. So they all have base 10. That's really important. When they all have the same base and they're raised to an exponent, they're being multiplied together, you want to add the exponents together. So that should be review. So we're going to add negative 11 to 24 to 30. And you should get 84 times 10 to the 43. Divided by 2 times 10 to the 22nd. Well, now we're working with really simple numbers. So we're left with 42 times 10 to the 21st. So when we divide our base numbers that have exponents, we're going to subtract them. Newtons, and we want to make sure it's in scientific notation, so 4.2, move our decimal one place to the left, times 10 to the 22 newtons. Okay? So when you plug that in your calculator, that's your second method. You all know how to do that. You should get 3.53 times 10 to the 22nd newtons. Go ahead and verify now that both of these are the same. And then start your next video.